Hi viewers, good morning, welcome to Dizzy classes. In our day-to-day life, we come across different situations where we are not in a position to give the exact values without knowing them. For example, can you tell the exact height of the tree without measuring it? Likewise, can you give the exact price of the doll without seeing its price tag? Also observe this, can you tell the area of this field without knowing its measurements? Is it possible? Of course, in all these situations, unless we know the exact value, they are unknowns to us. How do we use these unknowns? In general, if we observe, for finding the areas of plane figures, we write formulae and those formulae contains these unknowns. Now, let us see some formulae and what are the unknowns in that. If we observe this, the figure on the screen is a rectangle of whose area is L into B. Likewise, the next one which you can see on the screen is a triangle whose area is half into base into height, which we write like half BH. And also the area of a trapezium is half H into A plus B. In this we can observe that H, A and B are unknowns. Now, to find these unknowns in different contexts, we use formulae containing monomials and binomials. Do you know, in the following formulae, identify which are monomials and which are binomials. The first one is area of a rectangle, that is the first figure which we have seen, in which area of rectangle is given L into B. The next one is area of triangle. Area of triangle is equal to half into base into height and we write the same as half BH. And the third one is area of trapezium is equal to half H into A plus B. Now, how do we make use of these formulae? Let us see. In our day-to-day life situations, we come across different examples. Let us see one example. If the length of a rectangle is 3 units more than its breadth, then express its area in terms of its breadth. Here in this we can observe that the two measurements are interrelated. Now, this is the rectangle of whose breadth we consider like x and its length is taken x plus 3. What will be its area? Area is equal to length into breadth we know. So, length is taken x plus 3 and breadth is x. So, its area is x plus 3 times x, which we write x plus 3 into x. X into x plus 3 is the product of a monomial and a binomial. How do you find the product of a monomial and a binomial? Do you know? Now, let us learn multiplication of monomials and binomials. Now, to understand that, let us consider one activity. Let the length of this line segment be 1 unit. If we consider one line segment, here its length is 1 unit. Now, we are arranging two line segments side by side, then each one is 1 unit. So, 1 unit plus 1 unit is equal to 2 units. Likewise, when we arrange 3 line segments each of 1 unit length, 1 plus 1 plus 1 is equal to 3 units. If we continue like this, suppose we consider x line segments each of length 1 unit, 1 plus 1 plus 1 plus etc. Like this, so many are arranged. Already we discussed what is an unknown. Here we do not know how many such line segments are arranged. If x such line segments are arranged, then 1 plus 1 plus 1 plus etc. x times they are arranged, then its length will become x units. Now, let us see this. Okay. Now, let us understand the same in one more way. Just observe this. Here, when one line segment is there, it is of length 1 unit. When two line segments are arranged side by side, we are getting a length of 2 units. And observe how the same unit line segments are moving. The 3 line segments together form 3 units length, and the 4 line segments form 4 units length, and like that so many line segments are arranged side by side, and we are getting a length of x units. Now, here we observe that the line segments are arranged side by side, that is how we are getting the length. If these line segments are arranged in the other way, that is in the projected manner, and the projection is made in the other dimension, say breadth, how will it be? Let us see. Here we can observe that already we discussed that each one is 1 unit. Earlier we arranged them horizontally, now arranged them one below the other, and it is the projection of that, and it is projected along the breadth. When they are arranged such that its breadth is 1 unit, already we know that the length is 1 unit, now breadth is also 1 unit. So, its area is 1 square unit. Because it is a square, area is side into side, that is 1 into 1, 1 square unit. Okay. So, this is the way in which we can understand this. Now, let us see the activity related to this. Now, we are considering a line segment of length x units and another line segment of length x units. Then when they are placed side by side, their length is 1 plus 1 plus 1 plus etc. 2x times. So, the total length is 2x units. The total length of the line segment, when two line segments of length x and x are arranged side by side, we get a total length of 2x units. That is how we can say that x plus x is equal to 2x. Now, we are considering a line segment of length 1 unit and they are arranged or projected in the other dimension. They are arranged along the breadth. Now, you can observe that the line segments are arranged one below the other and they are arranged in such a manner that the length of the line segment is equal to the breadth. What is the shape formed here? Observe. The shape formed is a square whose area is 1 square unit. Now, in the same manner, what happens if a line segment of length x units is taken? Now, let us see the animation related to this. A line segment of length x units is taken and it is projected along the breadth. Now, when the line segments are arranged along the breadth such that the breadth is equal to its length, then what will be its area, what is the figure formed? Let us observe. We can observe that the line segments are so arranged that their length is equal to breadth. We can see that the same line segment is becoming equal, and in this the square that is blue in color is representing one square unit area. Like that we have several squares in that. Okay. Now, on the other hand, here we can observe that a line segment of length x units is arranged. This is 1 plus 1 plus etc. 1. So, the length of this line segment is x units. Already we discussed x is unknown. How many such line segments are there in this? We do not know. And likewise this side also we have 1 plus etc. the line segments, and we do not know how many line segments are arranged, but the total length x is equal to the total length x, which means how many line segments are arranged here? The same number of segments are arranged this side. Then we get a square whose area is x into x, x square. So, already we discussed this is 1 square unit, this is 1 square unit. So, its area is 1 square unit. So, this x square contains square units 1, 2, 3, 4 like that. So, total its area is x square square units. The figure is a square whose area is x into x is equal to x square square units. Here we are considering 1 unit segments x in one direction, that is length is taken x, and such type of unit line segments are taken which is not equal to x. Earlier we have seen that the unit line segments are x in number. Now the unit line segments are taken more. So, we are considering it like y. Then the shape formed here is a rectangle. We know that formula for area of a rectangle is length into breadth. So, x into y, xy square units. Why we are calling square units? Because here this is 1 square unit. Like this we have so many squares, each one is of 1 square unit. So, this total area is xy square units. Now, let us go for the next animation. Now, actually here we are going to learn the product of two monomials. Here consider two monomials, say 2x and 3y. In this red line represents x and blue line represents y. So, we have 2x. So, we can observe that 2 line segments are taken and 3y. So, 3 blue line segments are taken. Now, what happened here? Say we can observe that x length and y width, one rectangle is formed whose area is xy. Like that, how many rectangles are there you count? You can observe that there are 6 rectangles formed. So, it is 6xy. So, we can observe that the product of the two monomials 2x into 3y is equal to 6xy. Now, let us go for the product of a monomial and a binomial. Here for this again we consider a monomial and a binomial. Here consider a monomial 2x and a binomial x plus 2y. Now, let us consider a monomial 2x and a binomial x plus 2y. Here again each red line represents x and green line represents y. Now, here again we can observe that red line segment represent x and green line segment represent y. 2x means we considered 2 red line segments, and x plus 2y, along the breadth we took 1 red line segment and 2 green line segments. Now, what are the different shapes formed you observe? Easily you can observe that 2 squares are formed and 4 rectangles. In this, the first 2 are squares, each of length x units. So, each square is of area x square. 2 such squares are there. So, it is 2x square. Like that, when we consider the rectangle, its length is x and breadth is y. So, its area is xy. How many such rectangles are formed? 4. So, its total area is 4xy. So, 2x into x plus 2y is equal to 2x square plus 4xy. Now, finally, let us go for the product of 2 binomials. How do we multiply 2 binomials? Let us see. Consider 2 binomials, 2x plus y and x plus 2y. In this again we can observe that the blue line segment represent x and green line segment represent y. 2x plus y, along the length or horizontal line segments we can see 2 blue line segments, each one represent x. So, x plus y, and along the breadth you have one blue line segment which represent x and 2 green line segments y and y. So, along the breadth it is x plus 2y and along the length it is 2x plus y. Now, what happens? How many squares are formed and how many rectangles? We can observe that there are 2 large squares, 2 small squares and 5 rectangles. The first one, second one, 2 large squares, then 5 rectangles and finally 2 small squares. As we know, blue line segment is the length of x. It is a square of side x units. So, its area is x square. 2 such blue squares are there. So, the 2 blue squares area is 2x square. Likewise, if we observe the rectangles, each one is of area xy square units. We have 5 such rectangles. So, its area is 5xy. And finally, the small square of side y units, and we have 2 such small squares. So, its area is 2y square. So, easily we can observe that the product of 2x plus y and x plus 2y is 2x square plus 5xy plus 2y square. Okay students, till now we have seen how to multiply or how to find the product of monomials and binomials. Now, let us see what we have learnt. In the above discussed figures, we observe that total area is always equal to the sum of areas of its parts, and further we can observe that x plus x is always equal to 2x, because x is the length of one line segment and another x is the length of another line segment. When they are arranged side by side, their sum is x plus x, 2x, which is the total length of the line segment. Whereas, if we consider the product x into x we are considering one along length and one along breadth, because of which we are getting a square whose area is x square. Further, we observe the examples like product of 2 monomials 2x and 3y, and 2x into 3y is equal to 6xy. Also, we have seen the example of product of a monomial and a binomial. 2x into x plus 2y is equal to 2x square plus 4xy. The last example which we have seen is the product of 2 binomials. 2x plus y times x plus 2y is equal to 2x square plus 5xy plus 2y square. Okay students, till now we have learnt how to find the product of monomials and binomials. Now I am going to give you few more questions for further learning. You try to solve those problems, you take the help of your teacher, you complete those problems and show it to your teacher. Okay? Now I am going to give you some problems, note down. Questions for further learning. Find the product of 3x plus y into x plus 2y. Okay? Note down. Second problem. Write a 2-digit number and the number obtained by reversing the digits in the algebraic form and then find their product. Okay children, note down the next problem. Is the product of two binomials has always 4 terms. When will it become possible? Explain. How do you make use of distributive property for finding the product of a monomial and a binomial? And note down the last problem. Note down the last question. Length, breadth and height of a cuboid are in the ratio of 3:2:1. Express its volume in terms of its height. Okay students, till now we learnt multiplication of algebraic expressions. In that we learnt how to determine the product of monomials, monomial and a binomial, and binomial and a binomial. We will learn about few more topics in our next session. Thank you.